All right. You've been working on factoring by unfoiling. Okay. That's this right here. Primarily when there's three terms, but also when there's two terms that are a difference of squares, you unfoil. Okay. So that was the first homework. All right. You've also been working on the second homework, which was to factor out the GCF if necessary and to make sure you factored again if it was necessary. Okay. In this video, I want to do a little preview of the remaining parts of this. So this video is going to look at, well, what do you do when there's four terms and you're being asked to factor something that has four terms, okay? So it really helps if you would have looked at this before class where we cover it, okay? So I just want to do a couple of problems. So we're looking at factoring when you have four terms. Okay. All right. So this is going to require factoring by grouping. So it's a little different. You can do it the regular way or using the box. Okay. Using the box method. Okay. All right. And both are fine. Sometimes one clicks more so than the other. The box method just leaves out one of the hardest steps. And so that's why a lot of people really like that one. Okay, so here's what I'm talking about. What if you were asked to factor? So I'm going to do three examples. Okay, what if you were asked to factor x to the third minus 3x squared plus 5x minus 15? So it has four terms. It doesn't have three terms. Okay, so if you're going to do it the regular way, the idea is this. You're going to group together the first two, and I don't like to put parentheses around them. I like to put the parentheses underneath them because sometimes this sign right here is negative, and you can really get messed up on your signs if you're not careful. So just in your mind, think about how we're going to group together the first two and group together the last two. Also, I will say that sometimes you have to rearrange the terms that they give you initially to get it so that you can do this. So sometimes what you initially try doesn't work so well, and it turns out you need to rearrange the terms. Okay, but this one is just a quick preview, giving you the big idea of what we're doing. All right, so what you do is you only focus on these first two, and you look only at those two, and you try to figure out what you can factor out of those two terms. And see how there's an x squared common? So this is like the homework you did last night, factoring out a GCF. There's three x's multiplied together there and two there, so you can pull out x to the second power. Then what's left is an x here and a 3 there with a minus. Because if I were to distribute, I would get x to the third minus 3x squared. Now leave that alone and move to the two terms you see at the end. So what's common is a 5. So I'm going to factor, oops, let me change back to red. Okay, so I'm going to factor out a 5 because it's common. And then I'm going to look at what's left. And what I notice is I would need an x here and a 3 here with a minus. Okay. Then if I were to distribute, I would get 5x minus 15. So now here's the hard step. This is why sometimes I show you the box method, because this is the step that people struggle the most on. Do you see how this x minus 3 is common to this first part and to the second part? Okay, think of it almost like this, like x squared with something in parentheses plus 5 times the same thing in parentheses. Couldn't you factor that p out, pull it out in front, and you would have an x squared plus 5 left if you pulled a p out of both of those? Now that you typically can do pretty easily, but I need you to see the p as being this thing in parentheses. This is your p. Okay? So in reality, you don't do that. What you do is you pull the x minus 3 out in front because it's the thing in parentheses. It's the thing in the parentheses. And then what's left is x squared plus 5. This would be how you would factor our original problem, okay? And see that x is still squared on that second one, but that being a 5 and that being a plus, you really can't break that down anymore, okay? All right, now I want to do that same problem, but I'm going to show you the box method because a lot of people have a lot of success with the box method. They never miss them, and it's kind of a fun idea. The box method is based on the concept that if you wanted the area of a rectangle, you would do length times width, okay? And what you do is you think about the x to the third and all of those different terms as being the areas. So we're still trying to factor this right here. And I'll show you both ways when we do these problems in class. So what it is those 4 terms are like the areas of these 4 rooms, like you're trying to get carpet for your 4 rooms in your house. And the answer to the question is going to be what this turns out to be on the side and what this turns out to be. But see, to get that x to the third, you had to multiply something here with something up in that spot, okay? All right, let me just show you how it works because this is a lot of fun, and like I said, I see a lot of people having a lot of success with the box method. All right, so here's your plan. Let me change to blue. What you do is you look at the x to the third and the 5x, look at these two, and you think about how there's an x common. Right here, I'm going to put an x. This needs to be the GCF. If you don't pull out the greatest common factor, the rest of it falls apart. But if you get that right, the rest of this is just a little puzzle based on area being length times width. So if this is the area, and you already have x here, then this needs to be x squared. And then think about a rectangle. If this is x, then this is also x. And so if the area is 5x, and you already have x coming from above, then this needs to be 5. And then now let's look at this one. If this is x, let me move that out of the way. If this is x right here, x squared, then this is also x squared because this is a rectangle. So these would have the same length. So that would have to be -3 up there. And then your answer to the question is this times this. And it doesn't matter the order that you write them in. So you could have written x squared plus 5 and then the x minus 3 or the other way around. And you're done. And what the box method avoids is this step of having to go from that kind of awkward intermediate step to the final answer. People forget to do that. They lose track of what they're trying to do, okay? All right, so this is called the box. This is the regular way of factoring. Oh, sorry, my writing's so bad. My elbow is on the edge of the table. And this is the box method, okay? So let me just show you another one. We'll do some more in class, but it really helps if you can preview this before you come to class. All right, so what if we had this to factor? xy plus 4x minus 2y minus 8. And let's suppose we're going to start with the box. Let me move that down a little bit. Okay. All right, so let's use the box idea. Okay, I need to move that up. Sorry. Because the xy, the 4x, the negative 2y, make sure you keep the sign that's in front of it, and the negative 8. Those are all the areas of the individual rooms, okay? So now we look and we say to ourselves, okay, what's the greatest common factor? What's the biggest thing common to both xy and negative 2y? And do you see that it's y? That's the key. If you get that right, the rest of it's just length times width. Then over here, wouldn't you need an x so that x times y would give you xy? And if over here is x, then this would also be x. So that must be 4. So x times 4 would be 4x. And then if it's y here at the top, this needs to be negative 2. So negative 2 times y would give me negative 2y. And then this is sort of a check. See how negative 2 times 4 does give me the negative 8. So my answer is x minus 2 times y plus 4, take the sign of whatever it is, and it doesn't matter the order. It would have been okay to write y plus 4 and then put the x minus 2 next. Okay, that would also have been correct. That's the box method. A lot of people like it. Some prefer, they've already kind of learned a little bit of this before, and they're just reviewing. Some prefer factoring by grouping the regular way. So what they do is they look at these first two terms and they notice the x was common. Here's an x and here's an x. So they bring out the x and y plus 4 is left. Now this one's a little trickier than the last one because I put a minus there. When you look at the 2 and the 8, you know 2 is common, and you can pull out a 2 or a negative 2. The thing is, you need whatever's in parentheses here to match up with the y plus 4. So you need to pull out a negative 2. And then what you'd have here is y plus 4. Okay? And then just double check yourself. Make sure you didn't mess anything up. That's negative 2y minus 8. This is xy plus 4x. So far, what I've written is equivalent to the original. I've just got it not finished yet, but on the way to being factored. Now, here's the hard part for most students. That y plus 4 has to be thought of as a single entity. Think of it as the thing in parentheses. Almost think of it like a p. We do that kind of light. See how the p is common, so it could be pulled out in front, and what would be left would be the x minus the 2. But the thing in parentheses is really y plus 4, isn't it? So your final answer would be y plus 4 times x minus 2. And again, it wouldn't have mattered which way you wrote it. This is just typically how it would have happened on this one. So this would have been correct as well. So if that part of seeing the y plus 4 as that common piece, the thing in parentheses has to be common to both, and then you pull it out in front like I did here. Let me erase that a little bit, clean that up a little bit. See, so this right here was that common p that I saw. If that makes sense to you to do it the regular way, I'm fine with that. It's good. Okay. The box just, I found, allowed some people who were struggling with the regular way to figure it out. Okay. All right, so let's work on just that part. So there's one question at the end of your previous homework that kind of leads into this, something to this effect. Do you remember one like this? And it said to factor. And so that one might have caused you some problems. It had that x minus 1 that was common. I was trying to do that to preview what we needed to do today. So that x minus 1, that part in parentheses, was the same on both. So that part in parentheses could be pulled out, which would leave you x plus 5. You just got to get used to seeing this as a chunk that can be factored out of two terms. And so that p is really the x minus 1, isn't it? And so then that would be the way to finish it. Okay. This one right here was kind of like an intermediate step. Like they gave you a problem that was halfway done. That's what made it so hard. Okay. So I'm going to stop the video here. That just gives you a preview of how to factor 4 terms by grouping. Factoring by grouping is kind of a challenge to do by unfoiling. Sometimes you can get it all to work, but either factoring by grouping the regular way or by using the box are the two main approaches people use.